As mentioned, my name is Emily Anderson, and I'm going to talk today about advanced analytics with the OSIsoft Pi system. A bit of background about me: I'm an analytics engineer with Seeq, one of the OSIsoft partners. We are an advanced analytics company that leverages your Pi data to bring in additional insights. So my role as an analytics engineer is to work with our customers to gain insights from their data, and we'll talk through some of those use cases today. A bit more about my background: I came from process automation, doing some control system configuration, particularly for life sciences industry applications, and so batch processes are near and dear to my heart. So the agenda for today: I'll be giving you a brief introduction to Seeq, talking about some of the different types of analytics, as well as how we integrate with the OSIsoft Pi suite of products, as well as going through some use cases: asset availability, looking at CIP cycles; yield, looking at an order fill analysis, as well as product quality. And then we will take some time to reflect on our use cases and how we can leverage those advanced analytics tools moving forward. So looking at the different types of analytics, I like to characterize them in a way of thinking about what question I want to answer when I'm diving into my data. So we can talk about descriptive analytics: what happened, creating and sharing those insights to inform decisions plant-wide. Prescriptive analytics: what should happen, so that way I can evaluate my options and make decisions that will optimize my outcomes. Monitoring: so what is happening right now, and are things progressing in the way that I expect? Is there any action that I need to take to keep us on track? Predictive analytics: what is going to happen, predicting maintenance so that you can schedule it in a more routine way, and making sure that you're having improved batch outcomes. And then diagnostic: why did something happen? So if you've had something that's gone wrong, doing that root cause analysis to understand how you can improve it in the future. So a little bit more about Seeq. We're an advanced analytics platform, and in order to help you maximize the data that you have stored in Pi, as well as this additional wealth of information characterized by your Pi asset framework and event frames, we integrate with all of these OSIsoft offerings. And so to come in a bit more in depth here, we can bring in your data. We also leverage the asset framework structure to help you be able to browse through things quicker, and leverage that context that's coming from your event frames. We can also generate our content and bring it back into Pi Vision and bring it back to leverage those Pi notifications. So where an advanced analytics application really sits when working with Pi is for some of that data cleansing, ad hoc contextualization, collaborating, and having that knowledge capture to do the different types of analytics that we've talked about. And so now I want to get into our first use case. So this is talking about CIP cycles. For those of you who might not be familiar with the acronym, CIP stands for Clean in Place. And what's happening during these cycles is you've run a bunch of product through your system. You want to be sure that you're producing with consistent quality and cleanliness. So in between these production runs, you're cycling through and flushing cleaning solution and rinsing solution to make sure that your equipment is clean and ready for your next production run. And so what we want to do here is analyze these CIP cycles, which are often time-based, and compare them to our critical process parameters in order to understand if there's any way that we can optimize these to save some time and get our equipment online faster. So looking here, this is coming into the Seeq screen, and you can see what we'll do is bring in our CIP phases, which are the different cycles that I'm running, so different wash cycles and rinse cycles. We'll bring those onto the screen and characterize them by these little green bars up at the top. And this is just showing in time what we can do. I can add additional context here so to better understand what's happening in this capsules pane. And we can bring in any additional metadata that might be affiliated with your CIP cycles. So I can look at the duration to understand exactly how long I'm in each of these cleaning phases, as well as get a better context for what's actually happening during each of these cycles. So each of those times of those green bars. When am I in a pre-rinse? When am I in a wash? And when am I most specifically in my final rinse phase? So I can better understand what's happening at each of these times. So now that I'm looking at the context around those cleaning cycles, what I really need to know is, let's get some data on here to see what's actually happening during this time. So the data that I have here is the flow rate and the conductivity. So you can kind of notice that you're going to be flushing through fluid, different types of cleaning solutions through your vessel. So your flow rate is going to be on through most of these batches, as you'd expect. And your conductivity is the critical process parameter that you want to maintain throughout the CIP to show that you're really achieving the cleanliness that you desire. And then you want to bring that conductivity back down so that when you're bringing product through your vessel, you're not infusing it with cleaning solution. So specifically what I want to look at here is I could notice when I look at my critical process parameter, that conductivity signal at the bottom, I can see that I actually drop in my conductivity during that final rinse, but I'm still flowing for quite a while. So to me, this indicates a period of potential savings where I might be able to optimize that final rinse because I've achieved my critical process parameter, before, and I'm continuing to flow. So if I want to characterize that specific point in time, what I can do is focus on how to identify these periods of optimization. And that's when I have flow, which are now these brown bars at the top of the screen, searching for times with flow, and then looking for additional times with low conductivity. So that's kind of characterizing these periods of potential savings. And then not only do I want to see both of these things individually, but what I really care about is what they're doing together. So only when both of those conditions are present is what I want to focus on. So I can search for my low conductivity here just through a simple wizard, and then come through and see specifically those periods of time. And so if I want to look into my overcleaning events, I'll come in here and we'll add some additional contextualization to these capsules at the top of the screen. And you can see we've identified periods with low flow and conductivity, these pink capsules at the top, as well as our specific overcleaning. So I only really want to know when I'm actually running a CIP and seeing this behavior. I don't want to bring in any normal process running conditions to this. And so you can see I'm just taking these building blocks and bringing them together. So looking at one time and another, and then making sure I can zoom in specifically on my key period of interest. And so that way I can see this overcleaning, and then coming back into the capsules pane, I can have a quick ad hoc view of how much time I could potentially save in the duration of this overcleaning capsule. So I can see here, this is about a 17-minute potential savings. And maybe the best way to characterize the value of this is not through the additional time. So it's great to be able to bring your equipment back online faster, but maybe the key metric here is totalizing that flow so I understand how much of the final rinse utility am I really saving every time I'm in this 17-minute overcleaning period. So if I can optimize this, what does that savings look like by totalizing that flow rate? And so if I bring this metric into a scorecard, I can see here exactly my potential utility savings as well as my time savings. And that way I can do a further analysis and communicate this to maybe make some changes to my CIP cycles and improve the outcomes. So I can bring both of these views into a report and maybe communicate this up the chain or share it with some of my colleagues. And so this is a way that it will render and make it easy to share these insights that you're gaining from your analyses. So kind of a summation of this use case, we are looking at our clean in place cycles. When they're normally based on time, we want to compare those times to our key process parameters in order to understand if there's places where we can optimize, and then we want to quantify the savings that we can achieve by making those process changes. So the next use case that I'd like to talk about is yield. And so in this particular case, we're talking about filling orders and making sure that we're going to deliver our orders on time. So in this analysis here, we have our fill rate. And so we're filling so many cups per minute. And I know over the course of this order, I need to meet a certain amount of total cups filled by my shipping date so that I can make sure my full order is complete and ready to ship on time. That way I can optimize my logistics and also make sure that I'm not overproducing and having to have additional storage costs of extra product. So looking here, you can see my fill rate, filling in those cups per minute. What we want to start with is totalizing our fill rate to understand not just how many cups are being produced per minute, but how many total cups we're producing over the course of this order. So what we're going to do here is start contextualizing what is our current order. So in the last example, we mentioned pulling in pi event frames. Another way that we can do some ad hoc context is just to define the times. I know when I started filling, I can clearly see that in my data, and I know when I'm scheduled to have my next shipping date. So I'm just going to put that right up on the screen to better understand what is my timeline for meeting this order. And so now that I have this time period defined, I can totalize that fill rate over my order time in order to see how I'm progressing towards my end goal. And this is a great way to monitor what I'm doing now, but the insights I really want to gain are, am I on track to meet my final order? So based on how I've started, am I predicted to meet my final order target? And then based on that prediction, can I monitor what I'm currently producing to see if I'm tracking as expected? So what we're going to do here is create a prediction based on this totalized value, that blue signal that we saw, and then I can compare my order amount, which is this brown dotted line at the top here, and I can see when does that intersect with the predicted model of total cups filled that I've created. And here I can see I'm predicted to meet that order April 6th with a shipping date of April 7th. So it's a pretty good prediction. Or a pretty good result of a prediction, I'll say. So this is a tool where we're modeling our total cups filled based on just the number of days that are in our current order. So how long have we been filling for? And then we're projecting that out linearly based on the first 3 days. So once I've been filling for 3 days, I'm using that training model to predict it out into the future. We can do several different types of regression methods. In this case, we're using ordinary least squares, but there's different types of methods that are suitable for different types of analyses. And then when you're wanting to do some advanced prediction modeling, you can also look at the statistics to understand how accurate your model is to your data set. So now that I have my prediction in place, I want to continue to track how I'm actually progressing against my projection. So I can see coming down here to the scorecard. Let's see. I'm going a little fast. So here I can see my predicted total order, as well as the total cups I've filled so far to date, and how I am deviating from my prediction. So in this case, I'm about 1,200 cups shy of where I expect to be at this point. And that way, I can make changes to my process, maybe increase my fill rate to be sure that I'm going to track on time to my expected order. And that way, we'll be able to better understand that we ship on time. And so here we can monitor the trend view to kind of have a better visual versus that scorecard, which is going to just give you your KPIs. So looking at the yield we have here, we're determining if our production is on schedule for shipping, and then making sure that that prediction is what we're expecting and making any modifications as needed. And then we're tracking our progress as we get closer to that date to be sure that we're on target and we can make any changes as needed. And so for the last use case I want to talk about today, I want to shift gears a little bit from the food production side of food and beverage over to the beverage side of food and beverage. And we're going to talk about using our quality data, particularly in the case of monitoring the quality of beer that we're brewing. So here we want to use our historical good batches, and we can choose those based on our quality data in order to create a profile for some of our online data and use that for monitoring in the future. So a little bit of background on the science of the fermentation here. What you're looking at is some fermentation runs for different batches of beer. And as part of this fermentation process, the yeast is producing what we call diactyls. And that diactyl level is something that is measured as a quality measurement because if it's too high, it's going to produce kind of an off flavor in your brew. So we want to make sure that during this final period at the end of fermentation, which is called diactyl rest, that we're able to bring that diactyl level back down within what our acceptable range is to produce a quality tasting beer. And so what we have defined here are our 5 past fermentation batches that we want to analyze. And we want to look at that quality data. The interesting thing that you can see is, so our temperature signal would be some of the online data, and we're getting that pretty rapidly. So we're getting updates constantly about what our temperature is and monitoring that very closely. But quality data, sometimes we don't get those samples as often. So here you can see each of these samples is spaced by about a day. And so we want a way to better understand, based on the input of that temperature, whether we're on track to achieve our quality targets. And so I can evaluate this by looking at both of these inputs and then creating some kind of profile for my temperature curve that I can then use for all my diactyl rest periods moving forward to better understand what's happening. So let me come here and make sure I started this guy. Oh. Let's see. Is there a way to check my video here? Thank you. Ah, that's awesome. Perfect, thank you. Okay. Okay. So here you can see my acceptable diactyl level. It's projected across the screen. And here I can get a visual idea of which batches in these 5 that I'm looking at in my data set, which batches are my good batches. So I can do a quick comparison here to see when did my quality data fall back under that acceptable diactyl range, and see that those last 3 batches look like my good batches. That second one is pretty clearly kind of some off batch. And that first one I can see, while we did get pretty close to our diactyl level, it's running a bit longer than what I would expect. And so here I'm just selecting, based off of my ad hoc analysis, what inputs I want to use when I'm building this reference profile. So once I have these selected, I can take the inputs of my good batches and create a reference profile, so my expected temperature curve or some kind of golden curve that I can then apply moving forward. So here I'm looking at my fermentation temperature, and I'm using the inputs of my good batches, and then I'm actually applying this not only over the good batches that I used as my inputs, but I'm applying it off of every time that I'm in diactyl rest. And so once I have this reference profile defined, what I want to do is create some limits so that I can say, obviously, not every temperature curve is going to exactly match an average of several good batches, but I can use my standard deviation to add a minimum and maximum expected limit for that curve, and then apply it to my temperature signals moving forward. So here, I can see each of those 5 input batches along with my minimum and maximum for the temperature curve and that average. And I can see those kind of bad batches and how they're falling outside of my expected range. So once I have these signals, I can then use this to monitor all my diactyl rest periods moving forward for the temperature. And what you'll notice here is that top blue signal, that's my temperature signal. That's the online data that we're getting much more often. So even though my diactyl level, I'm not getting that quality data input as often, I can still monitor my temperature to understand if I'm on track to have a quality product before I get that next sample of data back. And so here you can see we can then apply this monitoring across multiple batches over a longer period of time to continue to look at every diactyl rest period and see how it's tracking against the profile that I've created based on those good batches that I've used in my history. One thing that I want to mention here as we're talking about integrating with Pi is having a way to take these analyses that we've done and bring them back into Pi Vision or bring that data back into your asset framework. So these signals that you've created, you can share them either through a reporting tool such as this or bring them back in to be a part of your greater ecosystem. So to kind of sum up this use case, we focused on looking at that temperature change and how critical it is of an input to our quality data. And then we leveraged that quality data looking backwards in time to understand what are my best runs and how can I use that information to create a profile that I want to follow moving forward in order to monitor my batches to ensure quality moving forward. And so from here, what I want to talk about is with all of these 3 use cases, there is added value that you can get and kind of an interface between your Pi data and then your advanced analytics. So bringing in those Pi event frames, that's something that we looked at, especially in our first use case, that can provide a lot of context to your data. And then you can build off of those to narrow into those key points of time that you want to understand what is happening. Also, being able to write those Seeq signals back into Pi so that anything that you've done with an advanced analytics application, you can bring in and make sure it's a part of your bigger ecosystem so that you can visualize it in any tool that you need and not be confined to one system. And so here, the most important thing that I want to touch on is these use cases are, I hope they've given you some ideas, but the people who are going to really understand what they want to do with analytics and how they want to contextualize their data are your subject matter experts. So these are the people who have maybe just years of that know-how type of knowledge. They understand their process, they understand the equipment, and they're going to be the ones who best understand holistically what it is they're looking for and how things can improve. And so when we're looking at when we're looking at empowering these employees, we're looking for an application that is self-directed, so something that they can use and get running quickly so that there's a really low cost of curiosity as you're starting to investigate your data. Something that's visual, so you can easily see the results as you're building them, and you can see any problems that you need to identify or any oddities in your data. Something that's iterative, so as very rarely do we get something correct the first time. So iterative means maybe you want to continue to tweak something, or maybe as you start building out an analysis, you see something that makes you think, hey, I want to pivot here because I thought I was looking for one interesting thing, but I found something completely different that I want to continue to look at. Flexible, so everyone has a different type of application, and even within the food and beverage industry, there's different processing styles, and so there's different tools and applications that you're going to want to be able to use instead of having a one-size-fits-all approach to your analytics. Scalable, so once we've done some of these use cases and we've done them on maybe a single piece of equipment, I want to be able to quickly scale that out in order to analyze across multiple plants and over longer periods of time so that I can take, thinking back to that CIP, I take that vessel 1 CIP savings and maybe save across multiple plants and multiple vessels to aggregate that total savings. And then something that is modern, so making sure that it's easy to integrate with your IT and easy for your users to use, something that's accessible and will start up quickly so that there's not a huge barrier to entry for getting started. And so with that, I wanted to open it up for any questions.
Have a hand for Emily.
So in your use case, you were showing just a single variable. What if you have, a combination of multiple variables that would drive that? You didn't really show, which is more common, right? That I've got multiple variables. Very seldom do I get as lucky as one indicator describes my process or can predict, quality. How do you deal with that type of scenario?
So I think it would be a different approach depending on which use case you're talking about. If you're thinking in terms of a prediction, you can bring multiple inputs into that prediction, into that predictive model, and then use the feedback in order to see how does your model track to your original signal, and then continue to build on that until you have a model that you think accurately reflects your data. If you're thinking of that use case where we're maybe not just looking at one critical process parameter, but several, building those capsules on top of each other, you can build those like capsule on top of capsule until you have like an overcleaning event that's verified based on maybe not only your conductivity, but some other parameters as well. So being able to identify each of those events and then see when all of those are true can help you leverage all of your data.
Hello. How do you decide if you will build an event frame or a capsule? What is your decision to make one or the other?
So what I've seen typically is that event frames are kind of embedded into your process. So you might have event frames for phases or things that are happening really in a standard and regular way, or something that you can characterize very consistently. And what I often use capsules for is more of that ad hoc. Maybe it doesn't need to be available to all of the other Pi users in my company. I just want to know something in particular to narrow down my analysis. I think that those more ad hoc type of cases are a great time to switch from those event frames to maybe a condition.
So when you write back to AF, does it write back just the values you've calculated, or does it also assist you with building analysis that'll run?
So the way we typically write back to AF, and let me know if I'm answering your question here, is we will write back to it as an attribute as part of your asset framework, and then you'll have a data reference to Seeq, and you can look at that specific attribute and use it in that way. Does that make sense? Okay. Any other questions?
Hi, Greg White from Eli Lilly. I just wanted to make sure I understand the write back on the golden batch.
Mm-hmm.
With those limits, do you use Pi to do a notification based on that real time, or can I just set up limits once I figured it out with the modeling that will do a notification for a batch as it's ongoing, or do I do that live monitoring up in Seeq?
So we can leverage the Pi notifications when we bring that data back into Pi, and that's probably the easiest way to do it. Okay, well, if there are not any more questions, it was a pleasure to present to you all today. I'll be in the Yosemite exhibition, so please feel free to stop by and talk with me more. Again, my name is Emily Anderson, and it was great to speak with you all.
Thank you, Emily.